good afternoon to everyone, and thank you all for coming on this beautiful late fall afternoon to talk about parrots and animal research and animal cognition. I want to start by talking about maybe it's the elephant or the parrot in the room, and that is the images we have of birds and parrots in popular culture. I mean, the theme of this year's festival, of course, is laughter and humor. And in popular culture, birds are often the butt of the joke. You know, we talk about your bird brain, meaning you're a bit of a ditz, or if you preen, you're vain, you know, and that's a parrot behavior, or that you parrot someone, that you don't have a mind of your own. And yet at the same time, birds and parrots are a huge source of humor for us. I mean, everybody knows the Monty Python sketch. The dead parrot, yes. And in fact, when Alex died in 2007, The Economist wrote this beautiful obituary and ended it by quoting that sketch, saying Alex, sadly, is an ex-parrot. So, you know, your work is deeply embedded in science. You're a well-trained, highly honored scientist, and yet, you know, you also work with animals that have this image in popular culture. I'm wondering, how much has that image affected your work to its detriment or to its benefit? Either been a kind of hindrance to be taken seriously or something that encourages people's interest in your work?
Both. I mean, the hindrance is definitely there. When I first put in my first grant proposal, this was 1970s. And most people who were working with birds, were working with pigeons, which are not the, you know, the brightest crayon in the box. And so I proposed to do this work with an animal that not only has, you know, unlike the chimpanzees, the closest relationship between the parrots and humans was 280 million years ago. Okay, not a good sign. Right. Unlike the dolphins with the large brains, this is a creature with a brain the size of a shelled walnut. And it's a pet. So that the other thing is that how can you maintain your objectivity? Right. So I put in this grant proposal, and the reviewers come back asking me what I'm smoking. I mean, it was, you know, it was real. They just could not get this. And it's been a lot of problems. And I would go over the years and giving these talks, and people would listen to the data and then say, but how does he do this? There's no cortex, no area of the brain that's functionally like ours. And I'd say, hey, you're the neuro folks. You know, you figure that out. These are just my data. And so it has, but I think it also spurred some of these people because they sat there going, he's doing the same kinds of things a 5-year-old child is doing. There's got to be something. And in 2005, Jarvis et al. Were et al. As 20 other people. They published a paper showing that these brains they work like ours. They don't look like ours, but they work like ours.
Right, and it's not just the size of the brain, it's the size relative to the actual entity.
Yes.
So even if it's a shelled walnut,
it's only a
for
1 pound parrot.
bird.
Yes.
Yeah.
And of course, the part of the brain that's responsible is relatively large relative to the rest of the brain. So that's another thing. But it has been a get-go. And I mean, we have a little clip, I don't know if it's going to work or not, of Alex. And you'll catch a little bit of his personality there. Not a whole lot, but you'll catch a little bit of his personality. And certainly over the years, I had to treat him like a colleague to maintain my scientific objectivity, but he didn't necessarily treat me like a colleague. and there are a lot of things that he did that were quite humorous. So.
Right. Can we talk a little bit about that before the clip? Because you definitely have a sense of humor in the book. And you start by talking about your, you know, attempt to maintain this kind of scientific, objective relationship to Alex, who was your companion, your colleague for 30 years. But in your early days, in your diary, your daily diary, as you were working with him, you describe him as incredibly stupid, awful grumpy, one grouchy bird, totally impossible today, doing his war dance, rather demanding if not properly rewarded. So give us a sense of Alex in all his fullness.
Yes. Well, it was very interesting because, you know, I mean, at one level, he was obviously, thinking back on it, many times very frustrated because you could tell that he understood the concepts that we were going for, and he couldn't yet produce the words. It was like a 2-year-old in their no stage. I mean, that's really the way to describe him for a lot of this. And just like those 2-year-olds, they have the ideas, they have the concepts. You can test them in ways that show that they have it, but they can't say what they want. And so he'd be so frustrated, and you could see him You know, and he'd ask for something and it wasn't what he wanted, and you'd give it to him and he'd throw it at you. And we'd go through this over and over, and you know, looking back on it, it was clear that he wanted something else, and it was like, can you give me the word for this, please? You know, and I wasn't getting it. But it was that type of behavior. Or he'd sit there and he'd do something perfectly on Monday, and I'd come in on Tuesday so excited. And Griffin now, the younger bird, is doing this, and I, you know, repeat the tasks to start getting data for statistical significance. And the little beak is up in the air, and it's like, I've already done that, you know.
He would turn his back on you if he didn't want to work with you.
Yeah. That's where we get that one grouchy bird, you know.
Do you think that has anything to do with it? I mean, I know they're from Congo, right? But you actually got him in Chicago,
yes.
right?
Yeah.
Well, why don't we take a look at the clip and just do a setup for us? What's the context here?
Okay, this was Alan Alda came to the Media Lab at MIT to work with us and to film some of the stuff we were doing. And it starts out with an older piece, background, and then we'll go to the Media Lab and you'll see Alan working with him, and it's such a lovely little clip.
Okay. It's an Alex.
That's actually Griffin up there.
One of your new parrots.
Yes, doing a Media Lab.
What is it? Good boy.
This is Alex.
You're right.
Yeah.
What a smart bird.
We first met Alex 10 years ago. He astonished us then.
What is it? Good boy.
Yeah,
That's
good
right.
birdie. Alex, what toy? Nail. Nail, that's right. You're a good birdie. Tell me what color? What color? Yellow. Yellow, that's right.
He even knew what things are made of.
What matter?
Good
Yeah,
boy.
that's right. Very good.
How many? Good boy, how many?
Irene Pepperberg was Alex's chief mentor.
2.
Good parrot. Good boy. 1, 2. Okay, one more question on these. What color bigger?
Back then, Irene and Alex worked at the University of Arizona.
You know, what color bigger?
Yellow.
Good boy. Good birdie.
Hello, Alex. But when we caught up with them recently, Irene was a visiting professor at MIT's Media Lab.
What, can Alex do any new things since we saw him last?
We're going to do a couple of new things. I'm going to start with some old things just to warm him up a little bit.
Okay.
So these are 2 objects, and we pulled them out of the tray. And the neat thing about this is if he didn't really understand what we were all talking about, he wouldn't be able to answer the several series of questions that I'm going to ask him. He would just have a single response to these things. So can you tell me what's here? What toy? Can you say better? Say better. That's right. Can you tell me how many? How many? Come on, can you tell me how many?
2.
Very good. We keep going. Can you tell me what's different? What's different?
Color.
Very good, different color. And can you tell me what color's smaller? What color's smaller? What color's smaller? What color's smaller? Green. You could have said it a little better, but that's a good boy. Can you tell me what number is gray?
Alex is now learning to recognize numbers up to 6, which is about as high as he can count.
Come on, what number is gray? Don't want to tell me? Well, tell me, what number is gray and you'll get a nut. What number is gray?
4.
Very good. Good boy. Okay, you
What
get
nut,
a nut.
right? You get a big nut.
You get a big nut.
How did he get to this point?
We do a modeling training system, which is really fun, which I just so happen to have something we're working on here.
Oh, okay.
We can demonstrate to
Oh,
him.
good, yeah.
So what we do is I act initially as the trainer,
Yeah.
and you act as the model for his behavior and his rival for my attention.
Oh, okay.
So I ask you about this,
Okay.
and if you get it right, you get to play with it.
Oh, okay.
Yeah. So you tell me, what's here?
Spoon.
Spoon, there you go. You got the spoon. That's right, he does with it, yeah. Okay, then we exchange roles, so he sees that I'm not always a questioner and you're not
Okay.
always a respondent, but it's a thing. And if I make a mistake, you can take the spoon away and scold me.
Oh, what is this? No, wrong.
Okay, now
Try
I get,
again now.
okay.
Try again.
Spoon.
Very good.
Okay.
Okay.
So he sees that not only any sound causes a transfer of the object, but a specific
I find this
sound.
very hard to believe that he's seeing all this
And he
and drawing
does.
these conclusions.
And he does. Can you tell me what toy? What toy? No, what toy? Come on, what toy? No, you're wrong. What toy?
Spoon.
Spoon. You're right.
Spoon.
Spoon.
Getting it on the
You're really missing out on a great spoon here.
See, look at that. Oh, he's a great trainer. We should hire him.
What toy? I'm serious about it. Huh? What?
You want a nut?
Want a nut? Sure you want a nut. Just tell us what the spoon is. You'll get it. Very good. Here, take that. Because that's the beginning of spoon. Now,
That's right.
if you do it a few more times, can you get him to get that N sound
Yes.
in there?
Say the whole thing.
Say the whole thing. What toy?
Spoon.
Oh, good. Okay.
You're beginning to get it.
It's sort of slow speech.
Alex has been working with Irene for some 23 years now, and has recently been joined by two fellow African greys, Griffin and Wart. Despite the bird's striking abilities, they look oddly out of place in a lab famous for being on the cutting edge of high tech. It was surrounded by...
So Alan Alda can charm just about anybody,
Yes,
including a
yes.
parrot.
And for the record, he is just as nice off stage as he is on stage. He's just a lovely man.
Talk a little bit about that model that you were working with Alex, because when you started in the late 70s, that wasn't the standard operating procedure, right?
No, when the 70s, everybody was into Skinnerian conditioning. Those of you who haven't had Psych 101 in a very long time, you lock an animal in a sound isolation box, you starve it down to 80% of its normal body weight. I mean, think about how you feel when you haven't had lunch. You know, I mean, and think about being 80%. I'm happy at 120% of my normal body weight. So you're in 80% of your normal body weight in your sound isolation box, and they flash some colored things at you. And you know, if you see a red light and it goes away, and then you see a red light and a green light, and if you hit the red light, you get a piece of food, and that's so matched to sample. And people can actually get some interesting behaviors that way, but you know, this isn't communication. And it struck me that if you want to communicate with a creature, you really want it to be socially. And of course, I'm coming up just at the point where all the ape people are getting criticized horribly for working with their animals one-on-one in social systems. And the only project that's getting any kind of, you know, kudos is the one where they actually locked an animal into a box with a keyboard. But I'm going, no, this isn't going to work. In the wild, these birds learn from watching one another. And it turns out that Dietmar Todt, who developed this modeling technique, was an ethologist watching nightingales learn from one another different songs. And he happened to be in a gray parrot lab. That's where he was. In Germany, the full professors have literally assistant professors working under them. That's how the term assistant professor came to be. And so he's starting to think, maybe we could train these birds to talk using this modeling technique. So as we showed there, it's a two-person system. Everybody thought I was crazy. Again, it works. We now have developed it and working with autistic children.
Right, this has been used to help in human communication.
Yeah. And again, people thought we were nuts. They still do. You know, we try to get this published and they say, no, you can't. This is based on a parrot. And I sit there and I go, the ABA system that you're working on, that's worked on rats and pigeons, hello, you know, but it doesn't seem to get across.
So the idea behind the model rival system, as we saw demonstrated there, is this notion that birds learn in social settings and they have complex social settings.
Yeah.
I want to rewind a bit. Before you met Alex, before you embarked on this work with him, you already had an affinity with birds, and it's something you talk about in the book. It's kind of a poignant story, but I think it's one many can relate to. So can you talk about your first relationship with a bird and his unusual name? It was a budgie?
He was a budgie. Well, his name wasn't no name. We just called him that in the book because I don't remember. I was 4 years old. But essentially, my father was working full-time. He was a teacher in the New York City public schools. He was getting his master's degree, and he was taking care of his ill mother. So he wasn't there. I mean, he kissed me good morning, and then he would disappear till the next morning many times. My mother would have been great in our generation, but this was, you know, I was born in 1949. At that point, you got pregnant, you got fired, And she wanted to be a career woman. She did not want children. She had raised her siblings when her mother died. And so she was very cold, and she was pretty much the refrigerator mother. And so my dad bought me this little budgie, and I joked about it that it was the only thing that talked to me all day. And I don't think you'd say he literally talked, but he would burble to me, and he would play with me, and he was my constant companion. And I really think I imprinted on this little guy. And get up in the morning, and he'd sit on the edge of my cereal bowl and, you know, take a bite of the cereal and stuff. He'd like that oatmeal, and, you know, he was around with me all day and would play with me. And, you know, this was my companion. We lived above a store. There were no children even around to play with, so.
So you had birds as pets all the way through college,
yes,
right?
I snuck one into the dorm, yes.
At what point did you know you have emotional attachments to them, sentimental? When did you and why did you want to form scientific bonds with them?
Well, I was getting my doctorate at Harvard in theoretical chemistry. Again, this was in the 70s. This was not a great time for women in science. I don't know how many people in the audience remember this, but 1972 was Bread and Roses, were the first beginnings of real, not just books being written, but women beginning to get very, involved and pushing for equality.
The beginning of the modern women's liberation movement, and okay.
Yeah, and what we call them, sensitivity groups and all this kind of thing to get together. And it was a very sexist situation at Harvard. My particular class in graduate school happened to have a lot of women in it. We thought it was great, that Harvard was at the forefront, breakthrough. It turned out that was the first year that men lost their draft deferment for graduate school. And Harvard had all these classes that had to be taught, and the teaching fellows were the people who were teaching them. So they had to let in all these women, because the guys who were supposed to come said, no, we don't want to go to Vietnam, we're going to go do this, this, and this, which would keep our deferment. So there were a bunch of us there, but the sexism was really rampant. And looking ahead, the chances of really getting a job in the field at that point, Harvard wouldn't hire a female professor because they said that they weren't any good enough. And we're sitting there going, but you're graduating us, there's again a disconnect. So I'm sitting there thinking, okay, where is my future heading? And there were NOVA programs on the signing chimps and the dolphin research. And there was the critical one, why do birds sing? Showing that birds learn their song and talking about this. And in that point, showing the primitive notions we had of similarities between bird brains and human brains on vocal learning. And the light bulb goes off, and I'm going, but birds talk, parrots talk. And my budgie was pretty smart, as to what he learned and how he communicated with me. And I'm thinking, this is what I want to do. And again, it was really considered crazy to try to do this work.
So in some ways, your experiences with your pets made you realize that birds could be worked with. You write in the book that they're actually easier to work with than the animals that we've had a lot of these breakthroughs with, chimpanzees. Yeah. Why is that? They talk, obviously.
Right, they talk. It's also, you see these, if you watch the pictures of the chimpanzees, most of the time they're very young chimpanzees, and you're seeing people, roughhousing with them, and it's so cute and fun. And you don't often see them working with the larger apes, which one of my colleagues who worked with apes, I'd come to a conference and she'd be, on crutches, and I'd go, what's the problem? Oh, I was roughhousing with the ape and he just tapped me and, flipped her over completely and, pulled out her back and things like that. They're extremely dangerous animals. I don't know how much, again, people have been reading, but there are people who have literally been dismembered by apes that they thought were tame. Dolphins also, they look so cute and they're smart, and you don't get in the tank with them. There have been, over the years, incidents where they've killed trainers who've, gotten in the tanks at the wrong times. And again, to work with a chimp, you need a huge facility. To work with a dolphin, you have to work in an aquarium. Hey, give me just an 8x10 room and a lab, and the parrot and I are very happy. So.
Have you ever had did you have any encounters with Alex or your other parrots, Griffin and Arthur, that have gone wrong? Have you suffered any injuries in the pursuit of science?
Nothing serious, but yeah, that beak exerts 75 pounds per square inch. So I have a couple of scars here and there. And usually it's been when I've been doing something stupid, and Alex or Griffin have, given me hints that I was doing something stupid, and I continued, and they just let go. The one really serious bite I got from Alex was really unintentional. Like my legs were crossed, he was sitting on my knee, we were doing some work, phone rang, and he lost his balance. And I went to try to stabilize him, and he just, you know, clomped on. And I'm realizing he's not doing this because he's angry at you. This is what he's keeping him from falling. And, you know, it's right here, and it's just so incredibly painful. And you're just trying, okay, it's okay, you know, trying to get him to climb, but, you know, it happens.
So let's talk about the goal of the work, which is to demonstrate, I mean, well, initially, to demonstrate whether parrots are capable of these kind of advanced linguistic or cognition skills that have been shown in chimpanzees. But what are you aiming for here? What's your objective?
Yeah. The idea is for people to understand that essentially bird brain should be a compliment, okay? Because these are very smart animals. And, you know, we have, I mean, scientifically there's the one thing of showing that this brain that's organized so differently from ours really functions like ours, and showing it absolutely. There's the conservation issue. I mean, in the wild, their habitat is completely being destroyed. My students were doing some field work in what was supposed to be a protected park, and were chased by machete-wielding poachers. Wow. Yeah, that was the end of our field work, and, you know, and the idea is that if we convince people that the birds need being saved, then that's going to save those areas for every other creature. It's the same work that Jane Goodall is doing. You know, save it for the chimps and you save it for everybody else. And also the idea of using these birds as models for intelligent learning systems, to get people to understand that it's not just the apes that can be used as models, but these parrots are really good models to help these children with disabilities.
And also, how do birds learn?
Yeah.
Right. So let's talk about that. Talk first about how is he able to make sounds?
Oh, it's,
you know, we saw that demonstration with the spoon and him putting together that word bit by bit, but how does he do that?
Well, it starts down here. He has a syrinx, and that's at the point where the, think about when you know, doctor's shown you your thing with bronchitis and the bronchial tubes split off. Okay, at the top where it starts, the trachea and the tubes go, birds have something called the syrinx. That's their sound source. We have a larynx up here. But theirs is down here. And the sound travels up that trachea, and that can move about 10%. And that gives you what, for humans, is the first formant in our vocalizations, which helps shape our speech. Then it goes up through their glottis, and they have a larynx, but the larynx doesn't do that much. The glottis is opening and closing the larynx, and again, giving you some flexibility. And there are all these muscles that control all of this. Then, just like us, depending on whether the tongue is front or back or up or down, the beak, just like our mouth, open and closed, it shapes the vocalizations. And he has to get all that together to say a word. So he has to learn it. And what's interesting is, just like a child, once he has a particular sound, he doesn't need a lot of training. So he learned, and basically he learned carrot overnight because he had parrot and he had key. Huh. And he's asking us on a Friday afternoon, you know, what's that? While we're munching on my leftover lunch. This is a bird who was, you know, the typical kid, vegetables, you know. And so he's sitting there watching us eating them and deciding, it's not killing them. Maybe I want to, you know, what's that? And so we give him a bite and we say carrot. And he'd take a bite and throw it and, you know, whatever. And the next morning, I'm at home. It's 9 o'clock in the morning. The students come in on the weekend so I can, you know, sleep in or do whatever. And the phone rings and they say, where are the carrots? I'm going, carrot? What are you talking about? Alex is asking for carrot. And so it's like, wait a minute, I'll grab some jeans and, you know, get in and buy, because, you know, we got to reward this. But essentially, he'd put it together overnight.
Wow. Yeah, you talk about, you would catch him kind of babbling to himself, sort of reviewing the words or these sounds, and learning's happening in that process.
Just like children, there was a book, Ruth Weir, 1962, wrote a book called Crib Talk, of how her child would do that at night. And so we got the idea of taping Alex at night. It was actually while I was at Northwestern. And we set this up, and again, you got to remember, this was in the 80s where we didn't have the incredible technology we had, so it was rather primitive type stuff. We set up, and we'd listen to him going, bean, sheen, keen, green, you know, playing with these sounds. It was,
can you talk a little bit about how you designed the experiments for him? So you start, it's interesting because you start teaching him the label, you don't call them words, right?
Yeah.
You call them object labels
Yeah,
or
color labels and things like that, yeah.
Yeah.
And there was a reason for that, because I'm coming in, starting this work in 77, 78. The ape people are beginning to get, you know, a lot of people are arguing with them that it's not language, it's not this, it's not that. And I'm thinking, I don't care what you call it, you know. Let's take away the baggage of calling it a word label, a little bit more, you know, set apart. And you start with object labels because you can then have him label things he wants.
right, and this idea that you start with what he wants.
Yes.
So you're not just sort of thrusting some foreign object at him, but
Right.
sort of figuring out first, what is
Yeah.
it that Alex wants?
Right, and of course the first thing he wanted was paper. And think about saying "p" without lips. It was very hard, and we had "er" for a very long time.
So give us a sense of how far Alex gets. What does his vocabulary consist of? How many labels?
Yeah. By the time he died, he could label 50 different objects, 7 colors, 5 shapes. He had quantities up to 8, which he had learned these, yeah, at the end we were working on 7 and 8. He had concepts of bigger and smaller, of same and different. He combined these labels to identify, request, refuse about 100 different things. He understood, I want X and want to go Y, and so X and Y were object or location labels. They were meaningful, intentional. If he asked for a banana, you gave him a grape, he'd throw it at you. I mean, this was, you know, hey lady, I asked you for, you know, banana, what's this? So it was, you know, and he started showing us, again, with these concepts of much more advanced abilities. So, for example, when you saw him with those, the Arabic numbers,
Yeah.
we trained them in the absence of quantities. So he had already shown that he understood, you know, like 6 blobs of something was 6. And we were working on comprehension, which is another very interesting study. And he showed that he had comprehension and production of that 6 blobs means 6. Then he also knew that 6, you know, was connected, the sound 6 was connected to a squiggle, and the same for the other labels. And then we did a study showing that he understood the connection between the blobs of things and the Arabic numbers without training.
So for example, you could, on that tray you saw, you could put the numeral 6, and then you could put, say, 5 of something, and say, Alex, which is bigger?
And he'd say 6. He'd give you, yeah. Because he knew that 6 meant 6 blobs of something.
Just clapping. It's an amazing accomplishment. Yeah. What is the accomplishment? I mean, I know you don't go this far, but
yeah.
For us, did Alex have language, or did he have advanced, like, language abilities,
Yeah.
I guess?
Okay. Language, you know, I say it, and I say it in a sense being kind of sarcastic, but Roger Fouts once said, language is whatever it is that apes can't do. Because whatever it was that he showed that his apes were doing, somebody said, but that's not language, because language is this.
Right.
I mean, Alex could not get up here and converse with you the way I'm conversing with you. It just wasn't going to happen. But he had an advanced communication system. I mean, he could let us know very clearly what he wanted, what he didn't want. He could, you know, tell us about his intelligence using the bits of language like things that he had. And so I talk about it as an advanced communication system. I talk about that he, you know, not that he was beginning to show theory of mind. I think he had it all along, but we were beginning to do studies that started showing some kind of theory of mind.
Theory of mind, in other words, he could look at another parrot, or maybe at you,
Me.
and understand what
I was thinking.
you were
yeah.
thinking, what you wanted, something like
And
that.
how to manipulate me into getting what he wanted, which...
Well, this is interesting because, you know, for any of us who have tried to learn a second language, you know, and one of the things that would let you know that you really have ability in that language is to be able to be funny in it, to tell
Yes.
a joke.
Yeah.
Now,
Yeah.
Alex was able to joke with you.
In some ways,
In
yes.
some ways. So
Yeah.
talk about those episodes.
Well, it was, you know,
and
when he
his
didn't,
humor.
yeah, when he didn't want to work. I mean, you saw the tray on that thing, and this is why I wanted to have this so I could refer to it. So, you know, we'd show him his tray like that, and you'd look at them, and you'd ask him a question, he'd take his beak and just throw everything off. Or he'd turn his back to you and start preening. Or if you asked him, you know, what color? 6. He'd give you all the colors but the color of the 6. And he'd repeat that.
Something's going on there.
So you knew something was going on, right? Because statistically, you know, you can't do that statistically. You have to, you know what's going on in it. And one of the funniest stories, I hope the student one of my students is here because she did this paper with me, and she's in Chicago now. So we're doing the comprehension study. And to go back a little bit, he understood concepts of, say, things like same and different and bigger and smaller already. So you'd show him two things, you'd say, what's same, what's different? And he'd say color, shape, matter, or none if nothing were same or different. And he transferred, we showed him sizes. So you'd say, what color bigger, what color smaller? He'd say, rose, or he'd say green, or he'd say none if nothing were bigger or smaller. So now we're doing a number comprehension study. Production, we had put objects, all these, tons of objects on a tray, colors, red and blue balls and blocks, all mixed in. We'd say, how many blue block? And he'd tell us. And he was right 80% of the time. Lots of times he would just, I'd ask him how many, he'd tell me all the numbers that weren't on the tray, that kind of thing, those were errors. But he basically got it. We had to show comprehension. So it's a similar type of task. We're having a bunch of things on the tray, and this particular time I'm coming in with 3, 4, and 6 blocks of different colors on the tray. And to show comprehension, the question was, what color 3? So he had to find the 3 things scattered amongst all these other things, figure out their color, and tell me. So I come in, and he had done the first 12 trials or so, right on, just great. It was a new task, it was fun. And then it started, it's the same old stuff. The tray's coming in, and again, he's doing all these, really annoying behaviors. And we start bribing him by using things like jelly bellies, and, and trying to get him so he could tell me what color 6, and you could have one of them for a reward. So I come in this day with the old stupid blocks, and he looks at me, and I look at him, what color 3? And he looks at me and goes, 5. And there are no 5 things on the tray. And I go, no, Alex, what color 3? And he looks at me and he goes, 5. And we do this a couple of times, and part of me is thinking, okay, I'm fighting with a parrot, Yeah, who has the PhD, right? And the other part of me is thinking, he's not throwing things on the floor. He's not doing any of these really annoying behaviors.
He's very composed.
He's very composed, and he's giving me what we call the look, which is, like I'm in charge here. And so finally I look at him and think, okay, smarty, what color 5? And no idea what he's going to say. And he looks at me and he goes, none. There are no 5 things on the tray. At which point I'm about ready to drop the tray because, as humans, we didn't have concept of 0 in Western society until like the 1500s or something. And here's this parrot, taking none from absence of same different to absence of stuff, which was a breakthrough of unbelievable. The other thing is, I realized he had figured out how to manipulate me into asking the question he wanted to answer. This is pretty good.
We're beyond the realm of science at this point.
Yeah, it started giving me, theory of mind. Yes, I can start going to these conferences on consciousness and have some data, yeah.
You also tell a story, and this goes to something you've talked about, his ability to play with words, or a couple of them. One, he comes up with this word banary.
Yeah.
And then one where he does something with the word nut.
Yes. This was at the Media Lab. And again, I don't know how many people here have had experience with the Media Lab in Boston. It's, anyway. The Media Lab is a freestanding part of MIT. It's supported, unlike most of the rest of MIT, it's supported by corporate foundation monies. And so these corporations throw millions at the Media Lab every year in exchange for intellectual property rights for what the Media Lab does. And just to give you an example, the fact that you can plug your camera into the computer directly and the pictures come up, it's actually very complicated technology to allow you to do that, and Media Lab people developed that. They did that, and Kodak had IP rights, to do that. So that's the kind of thing. And so I'm getting there, I come there as a visitor because people want to see how the birds learn, thinking maybe they can use that to train robots or intelligent learning systems. Right. But I get there and this is a paradise for building stuff. And at the very beginning of the clip you saw Griffin doing that little thing. It was a thing on serial learning where he learns to twist a thing if there's a twist signal. And the idea was stacking them and getting these kinds of things. We're also working on Interpet Explorer, a web browser for your parrot to keep them entertained when you were at work.
Because that's the thing about parrots, they get bored very easily,
Yes.
which maybe is true of all of us. that
Well, think about
learning
children,
isn't easy.
you know,
Yeah.
4-year-old child left alone all day in a playpen with a couple of toys. No, it doesn't work. So that's what you do with your bird when you leave it alone all day in this cage with a couple of things to chew. Anyway, so I start working on all these things, and the other thing about the Media Lab is twice a year, all these people come to visit and see what have we done with these millions of dollars. And so I'm setting up Interpet Explorer because I think these guys, and they're coming through in groups of the top CEOs are going around, and there are lots of them, and they come around for 5-7 minutes. That's it. You know, they want to see what you're doing, they move on to the next. And they come by, no, they want to see Alex do his phonemes. Okay, this was just, it's like your children sounding out, you know, it's phonetics, sounding out different things. We figured eventually, if we taught Alex to sound out letters, could he eventually start sounding out words? Not so much for reading, but to see if he understood that his words were made up of individual units of sound that could be put together. And you saw the beginnings of this where he's going s, n, and with a big space, because that p-oo is hard, the p and the oo. So we started having him do this, and this is what they wanted to see, so I'm thinking, fine. So we set this up, and, you know, Alex, what sound is blue? Shh, good birdie, you know, because it was SH. So he goes, want a nut, and we go, no, because, I mean, they're going to be there 5 minutes. We don't want him to be eating the nuts. So I go, you know, what sound is green? He goes, S, good birdie. Want nut? Okay, and no, Alex, wait. You know, he's getting annoyed, but I'm trying to get him to finish the task. And after 4 or 5 of these things, he just finally looks at me and he goes, you know, want a nut? N-a-t. And yeah, so not only, you know, do I have to spell it for you, stupid, but it's but it's also that he had jumped ahead of us. Because n and t were on the tray, but was not. So he had figured out already how to split apart his words and sound them out, even though we hadn't trained it.
You know, you talked earlier about how the work you've done has been used, I mean, it's really opened up a lot of ideas about human communication has been used with these children who have autism to help them communicate. But I wonder what you've learned about, I mean, in a sense, you're teaching them a second language that isn't theirs. You're teaching them how to communicate as a human. So what are you learning about how birds communicate? I mean, how much has that part of this opened for you through your work with Alex?
It has a lot because, again, even in the birdsong community, although that got me into it, the idea that birds learn their song, and Dietmar's idea that birds learn them from watching other birds, this again was not standard in the 70s. Peter Marler had taken a bunch of song sparrows, locked them in a sound isolation box, played them tapes of song sparrow, of white-crowned sparrow song and other songs. It was white-crowned sparrows playing those, and they only learned white-crowned sparrow song. They only learned it in a little period of time, and this was now dogma. That birds had this little, they called it a template, and it rejected all the wrong songs, and they had a sensitive critical period where they could only learn. Just like humans, you know, we only learn a language in a little period. Well, we don't. We know we can learn other things. We don't mean that sound so good, but we can learn it, I think. So in the late 70s, early 80s, Louis Baptiste was working with white-crowned sparrows again, ran out of caging space and thought, well, if I throw my white-crown in with a strawberry finch, it's not going to learn anything. It'd be the same as putting it in an isolation box. And he comes back the next spring, and there's his white-crowned sparrow singing a strawberry finch song. And it set up a huge battle in the song learning system about this social interaction and learning. And of course, Peter was he was the grand old man of this thing, and there are a few of us little upstarts yelling and saying, no, it's social interaction, social interaction. And it's been a huge, I mean, still to this day, it's quite a bit of argument about how much is learned and how much is not. But I think it helped open this up for those people looking at song learning to think about the effects of social interaction on learning.
What do you think your work has contributed to that area?
Very specifically, there have been some studies using multiple birds in an aviary, and it turns out that the juveniles actually listen to the adult birds singing against one another and learn the song of the dominant male. So again, they're watching this social interaction, eavesdropping, and learning, oh, he's the top guy, I'm going to learn from him. The female birds listen to the males singing and decide to mate with the guy who's the stronger and the better and the winner. They also do this eavesdropping. So again, the whole idea of looking at birds not just as individuals, but as part of this entire flock and learning from one another in particular ways is something that our work has contributed.
What about, though, I mean, obviously Alex's learning environment involved interaction with you.
Yeah.
And parrots are great mimickers,
yeah.
right? And he did learn to mimic things you talk
sounds,
about,
yeah.
sounds, and to be able to say the phrase, I'm sorry, in a context.
Yeah, without much contrition, yes.
Right. He wasn't really sorry.
Yes, but he learned the appropriate context in which to use it.
Yeah.
Somebody is screaming at you, you say this in your cute little parrot voice, and all of a sudden they go, oh,
But when do you know, how were you able to distinguish the mimicking from the cognating, I guess?
Okay, well the mimicking was basically the production of the sounds. And when we were able to show him multiple objects, and he had to listen to our questions to determine what to say. I mean, that was one of the things we showed on the tape, where if I just shown him those two objects, and every time he saw two objects he said two, it would probably be, it's stimulus response, it's a mimicky type thing. But he has to look at those two objects, and am I asking him how many? What color bigger? What color smaller? What matter bigger? What matter smaller? What's same? What's different? He had to listen to our questions. He had to be able to respond, or look at one object and say, okay, what color? Blue. What shape? Four corner. What matter? Wood. What toy? Block. The fact that he could answer all those different questions showed that he understood what those questions meant, and he understood the meaning of the labels he was using.
And he had concepts.
Yeah. Concepts, because you can only do that if you have a concept of color, so that he could look at neither of us are wearing a good example color, but
one of Alex's colors.
Yes, but he could look at our shirt, our jackets, and ask him what color, and he'd say gray. Right. Okay, and he would be trained on pieces of wood, but he could look at this, and if I had asked him what color your jacket is, he probably would say rose because it was close enough. And he's trained on a particular color in a laboratory, and yet you could do this. When we had film crews, they would always come and say, yeah, right, they'd pull out something from their jacket pocket and go, what color, what shape? And if it was in reason, he could tell them. It was not, and they, oh. Or they would, pull up, the fun one was, I'd say, okay, and I'd give him a little toy car. And for historical reasons, anything with four wheels was truck. So they'd be thinking car, and they'd, Alex, what's this? And he'd say truck. And they'd, go and say, that's his, name for it. And so he had these idiosyncratic labels. You couldn't cue him because you would be thinking it was something else. And yet he knew what this was.
So in some ways, Alex died just over 2 years ago, and that's a very sad part of your book.
Yeah.
Kind of going through that process, realizing you didn't have just a scientific relationship with him.
Yeah, and it still is a process.
Yeah. But in a way, I thought, as I was reading your book, that you, in some ways, got the last laugh with his death. It's a sad event,
Yes.
but in terms of the kind of outpouring of
Yes.
support, and the kind of recognition that the work you did was serious, because this is a theme throughout this book, that how do you get people to take this work seriously?
Yes, and I think, even to myself, the fact that, to have an obituary in The Economist, I'm sure when I die, I will not have one in The Economist.
And the Times,
yeah,
around the world.
Seriously, that's, that was something that really, and I think it also, I still have colleagues who are doubters. My editor sent, or rather the PR people sent the book for review to Nature. Now, Alex and Me is not a book that should be reviewed in Nature. Nature is a serious scientific publication. And the reviewer just absolutely, trashed the book. But he trashed it from a scientific standpoint, which was stupid. It was a memoir. It was always said it was a memoir. And yet, and I wrote back a rebuttal saying, look, if you're going to trash the science, go read Alex studies and tell me what you think of that, because that's a scientific book.
This is a book you published in 1999, or
yeah. But I still have colleagues whose, their attitude is if, you can't be objective. You had to have been cueing him. They simply won't believe that Alex could do what he did. But the majority of them have really, stepped back and thought about it a little bit more. I have had so many invitations, not just to things like this, which are great, but I mean last weekend I was at Yale, and I gave a talk to their behavioral neuroscience program. And I had had invitations before like that, but a lot more of those are coming in. People beginning to say, hey, let's hear some more of the science. Let's at least talk about it. Let's at least discuss it. Come, if you can answer our questions. And the answer, yes, I'd love to be there. I'd love to defend the work. And that is happening, and that's good.
What do you think accounts? I mean, you've been doing this for 30 years. You've gone through so many changes. I mean,
more than 30 now, but
okay, yeah. And then, science has changed so much. We've discovered a lot more, and yet there's still this resistance to this idea of recognizing these capabilities in animals. What do you think are the stakes there in kind of trying to maintain a distinction between animals and humans?
It's really hard. I mean, you look at all the stuff that's being done by Clayton Keselnik in England with the crows.
Okay,
Betty the crow, tool making crows and episodic memories and jays and all these things that animals are doing that nobody thought animals could do. It's an interesting thing because people like to have a separation between animals and humans for a myriad number of reasons. I mean, people ask me, are you a vegetarian? And I go, not entirely, but you know what, I eat very little meat. I live in Boston. I cannot get through a Boston winter without my, sheepskin-lined boots and my down jacket. I just can't. But I am wearing the same down jacket that I bought in 1999 when I moved back to Boston. I've got the same boots that I bought when I lived in Chicago, that I've had fixed so many times. Because the idea of eating animals or using them for experimental things, I mean, not just the kind of experiment I'm doing, but, sticking electrodes in their heads and using them for medical research, of wearing them. It's very hard to then think about them as intelligent beings, as intelligent as we are. And I'm not saying that the average cow can do what Alex did. But it's hard to where you draw the line between these things, because we thought birds were stupid.
Right.
And nobody studied cows. I mean, so much work. Everybody who has a dog knows their dogs are smart. But the person who doesn't have a dog doesn't look at it yet. The hot topic now is dog cognition, because people are beginning to scientifically show that what our hunches were about our dogs are correct. And so there's this idea of how can you experiment on animals? How can you eat them? How can you do all these things to them if they are sentient, intelligent beings? And so there's this desire, I think, to draw this line so we can, go out and buy the latest pair of shoes without thinking about where that leather comes from. And again, I'm not, I'm only here because of medical advances. I mean, I'm sure every single one of us, if it wasn't for penicillin or, something or else that was tested on an animal, we wouldn't be here today.
So is that why, because you do talk in the book that you are in favor of animal rights. You don't go that far.
But animal welfare is a separate issue from animal rights.
Okay. So where do you draw the line?
And that's it. I draw the line in terms of a respect for these animals, of realizing it's sort of like I don't want to sound hokey about this, but it's sort of like the Native Americans who, they would thank the deer before killing it and saying, because you are now part of me and I need you to live, and then when I go back to the soil, my body will, give the shoots that your great grand, deer will be eating and things like that. And it's a cycle. And there's a certain respect for using as little as possible, for not using, we don't need to use animals to test eyeshadow, so why do it? We do need animals to test flu, so yes, but to get into sort of a balance in our world and to treat the animals that are in our world as best we can. I mean, a lot of things have happened in the last decade of having better places for the animals to live, giving them anesthesias and things when we do the kinds of things we absolutely need to do. So it's a matter of a respect for and of, you're still drawing lines, but of being careful, much more careful where we're drawing them.
Well, we want to invite you to participate in this conversation. We are happy to take questions. I would be mindful, there's so many of you here, and I know a number of fans of Irene. Keep it to questions and try and be as short and succinct as you can be so we can get through as many as possible. And Jesse's going to bring around the microphone. There are a number of hands up.
Yeah. So we actually only have time for 2 questions.
Oh, 2 questions.
So,
okay.
Ooh, sorry.
Hi, I have 2 questions, but I'll try to make them real quick. In the handout for this, there was a sidebar about, from a book by Mark Hauser called Wild Justice, and it talked about compassion and empathy and altruism in animals. And I wondered if you had found, you've been talking a lot about intellectual stuff. Did you find anything of that nature in your studies? And also quickly, how is your research with Griffin going? How is he doing compared to Alex?
Good questions.
Well, I didn't actually
The first one was, did you find evidence of beyond intelligence, of compassion in animals? Yeah, and altruism.
Yeah, altruism is interesting. We're actually doing a study on that now, trying to see if the birds will cooperate. And the trick is they can pick, they work together and they can pick cups. And if they pick the green one, they both get nuts. They pick the pink one, they get a nut. Orange, the other bird gets a nut. And purple, nobody gets a nut. And just seeing if they will learn to work together on this. So that we're in the process of looking at that.
And then the second question was, what beyond Alex, you're working with Griffith now, how is that going? What's happening there?
Slowly, because it's interesting. Alex would interrupt all of Griffin's sessions. And it was interesting. He's the alpha bird. And Griffin, for a solid year, would look towards Alex's cage as if to say, so, what am I supposed to say? And he's getting out of that now, and he's beginning to work, and he's at the stage which Alex went through. You ask him about a color, he'll give you a color. It's not yet the right one, but he understands color, and there's certain labels that go under that, and shape, there's certain labels that go under that. And that is a stage, and children go through the same stage. I talked to the developmental psychologist, and so he's getting there. It's going to take a while, and that's a scary thing of trying to convince my colleagues to, keep us funded while we get him up to snuff.
Another question?
Do you think Alex had a sense of self, that he knew he was a bird, you're a person?
Oh, good question. Whether he thought he was a bird or a person. I don't know what he thought he was, but he definitely had a sense of self, a very self-importance. And he was, he was the alpha bird. If I came into the lab and did not greet him first, he would not work with me the rest of the day. And there's a definite pecking order in the lab. There's Alex, there's Griffin, there's Arthur. Arthur's the youngest. Griffin outweighed Alex by 50 grams. That's, in a 100-pound parrot, 1-pound parrot, a 450-pound parrot. Griffin was 500 grams. You would think that Griffin would take over, but Alex was very clearly in charge.
One more, actually.
The recent discovery of a gene for speech, has that anything to do with your work?
You're referencing another person's work?
Yeah, there's a recent discovery of a gene that's associated with human speech.
The gene associated with human speech?
Yes.
Oh,
FOXP2.
FOXP2.
Yeah.
FOXP2 is in birds. They've seen it in parakeets. They haven't looked at it in parrots. And it's responsible for similar things, control of the vocal system. There's a new paper in Science this week about FOXP2 and what it controls. It's partly a kind of a languagey type thing, but a lot of what it's controlled is the ability to produce sounds, the musculature of saying and talking and of singing.
Okay.
So it's a very complicated thing, but it does seem to be in birds, and there's papers, again, this week's Nature. There's a whole new article on it. I was reading the summary on the way here on the plane, so.
Do we have time for another?
So I'd like to thank Alison Cuddy and Irene Pepperberg so much for this conversation. And she will be available in the lobby for book signing and for additional questions.